Hello everyone. Through this video we are going to discuss how to solve system of linear equations using inverse of a matrix in the exercise of 4.6 in the exercise 4.6 in the chapter of determinants. But before starting with the exercise, we need to know actually how to the basic method to find out the solution of a system of linear equations. Suppose we consider the system of equations. Let us consider the following system of linear equations. The equations are a1x plus b1y plus c1z is equal to d1. Then a2x plus b2y plus c2z equals to d2. Then a3x plus b3y plus c3z equals to d3. Now in this case, what can we do? We can consider three separate matrices. That means the first matrix will be a matrix containing all the coefficients of the variables of these three equations. Then after, the second matrix will be a column matrix containing all the variables of these three equations. And then after, we shall come to the matrix containing all the three contents lying on the right hand sides of these three equations. So I am going to write, let capital A is equal to all the coefficients I am going to write here, a1 b1 c1, then a2 b2 c2, then after a3 b3 c3. So this is the first matrix, the coefficient matrix. Then next comes the variable matrix. It is a column matrix. So x, y, z I get here. Then after, I get the constant matrix, and that is d1, d2, d3. Now this system of equations, if we observe properly, this system of equations can be written in the form, therefore the given system of equations can be written in the form, can be written as capital A x is equal to b, because when I multiply this matrix A with matrix B, I shall be getting the entire left hand sides of these three equations, and on the other side matrix B will be placed, which will be giving us the result for all the three constants lying on the right hand sides in these three equations. So our intention is to derive what is the value of x, y and z, and that is known to be the process, the method by which we can solve this system of equations. To solve means what? To find out value of the unknown variables of the system. So what is to be done here? Let us see. To find out value of x, I have to do what? I have to multiply both the sides by A inverse, like this. Here in this case, this will be pre-multiplication, means I am multiplying A inverse just then keeping it in front of the terms given on both the sides. So this is called pre-multiplication by A inverse. So after this, what shall I get? A inverse A should be kept together keeping aside x, that is equal to A inverse B. we know that A inverse into A, the result will of course be the identity matrix I, that is equal to A inverse B, and this will imply X is equal to A inverse B. Now this is the way to find out, using this formula we can find out the solution of system of linear equations. But in this case there is a point to be noted, that is what A inverse is valid or it exists if determinant of A is a non-zero term. Means whenever, actually the formula for A inverse as we know is what, 1 by determinant of A into adjoint of A, yes or no, 1 by determinant of A into adjoint of A. Now to find out A inverse we must have to know these two quantities of course. So to find out value of A inverse, first we shall evaluate what is determinant of A. So determinant of A is will be obtained by expanding the determinant. Now if it comes as a zero quantity, in that case this entire thing will become not defined. So if it is not defined, it is not possible to find out A inverse. So either this system of equations will be inconsistent or will be having infinitely many solutions depending on conditions. So that part we do not have to study. Actually only those parts where solutions are available, only those things we need to study. So that is why in those cases where determinant of A is not equal to 0, in that case only A inverse will exist, and where there is A inverse there can be evaluation of values of these variables. So that's all. So after this we can start with the exercise. So in the main exercise part, what do we get? Only the important ones I am picking up in the exercise. So here we proceed with exercise 4.6. We shall directly come to the second part of this exercise. So question numbers, second part of this exercise is what, solve the system of linear equations using matrix method. So I'm going to write this part, solve the system of linear equations using matrix method. Matrix method means what? We need to find out inverse of a matrix and then we have to proceed with the formula which we have derived just now. Using matrix method, so I shall be starting with question number 11 because usually in boards exam it is seen that from question number 7 to 10 these questions are usually not asked. So the most important questions from this exercise starts with question number 11. So here goes question number 11. The system of equations are given to be, I shall be writing here, given equations are, what do I get here? Twice x plus y plus z is equal to 1. Then the next equation is x minus 2y, it should be minus 2y minus z is equal to 3 by 2, and then after what do I get? Thrice y minus 5z is equal to 9. So this is the system of equations given here. So I shall start writing. This is to be written in the form ax plus b. So I shall be writing this system of equations in ax plus b form such that capital A would come as only the coefficients we need to consider. From the first equation, from the left hand side, we shall be getting 2, 1, 1, as these are the coefficients of twice x, then y, then z. Then after coming to the second equation, the coefficients we get as 1, minus 2, minus 1. Again coming to the third equation, we see that there is no x term on the left hand side, so in place of coefficient of x, of course there will be 0. Then here it is 3, then after minus 5. After this I get value of x as x, y, z. Then after the constant matrix will be 1, then after 3 by 2, then after 9. So these are the respective terms we got here. After that, to find out inverse, actually for finding out solutions of this equation, we must have to get what is A inverse. Now for existence of A inverse, it is must that the determinant value should be a non-zero quantity. So first of all, let us find out what is the value of the determinant. Therefore determinant of A is equal to, I am going to expand along the first row. So 2 into 10 plus 3 it is, then after minus 1 I get here minus 5, then after 0, after that plus 1, then after I get 3, 0, and then after what would I get? It is 26 plus 5 plus 3. So my answer comes as 34, because 26 plus 8 it is 34. I get that it is a non-zero term, therefore A inverse exists. So I will write here, therefore A inverse exists. After that, what I have to find out? See, this is the formula for finding out A inverse. For A inverse, we know that 1 by determinant of A into adjoint of A. So for finding out adjoint of A, it is must that I have to find out the cofactors of the elements of A. So the cofactors of A are for my convenience, I am going to write down this matrix here so that it becomes easier for me to evaluate the cofactors. 2, 1, 1. Please do not write this part. This is for my own purpose I am writing here. So 1 minus 2 minus 1, then 0, 3, minus 5. So what did I get here? The cofactors are A11. I shall be getting sign convention. This is the sign convention to be used here. Plus, made a mistake. Plus, minus, minus, then plus, minus, plus. So this is the sign convention to be followed here. So I am going to write the cofactors as, first one it will be 13. It is 13. After that, let me first list this 1, 2. A 1 3, A 2 1, A 2 2, A 2 3, then A 3 1, then A 3 2, then A 3 3. So let us find out the values. This is 13. Then after I shall be getting this result for A12, it will be 5. I mean, will it be 5? Yes, negative, it will, negative sign convention will be there, and this is negative, so ultimately 5. Then A13, A13 comes as 3. Then for A21, what did I get? For A21 it will be minus of minus 5 minus 3, means it is 8. Then A22 will be, for the middle one, minus 10. So this is minus 10. And for the third place it will come as 6. It will become minus 6 because negative sign convention is there. Then A31 will be minus 1 plus 2, so it is 1 ultimately. Then A32, for A32 it is minus 2 minus 1, so ultimately it is positive 3. Then A33, for the last one, it will be 4 minus 1, so it is minus 5. So these are the cofactors of matrix A. And for finding out its adjoint of A will be equal to transpose of this cofactor matrix. I need to find out 13, 5, 3, then 8, minus 10, minus 6, then 1, 3, minus 5. Let's find its transpose. The result comes as 13, 8, 1, then 5, minus 10, 3, then after I get here 3, then minus 6, then after minus 5. So this is the result for adjoint of A. After this, therefore we get required inverse. A inverse is equal to, or just we can write inverse, this required part is not needed, directly we can write hence inverse A inverse is equal to 1 by determinant of A into adjoint of A. So I can put here 1 by the determinant value we already got as 34 into 13, 8, 1, then 5, minus 10, 3, then 3, minus 6, minus 5. So after this, what would I get? Therefore, for the equation actually we have to find out the variables, yes or no. So capital X is equal to A inverse B. Actually initially the equation was this one, AX is equal to B. From this I get this result following matrix multiplication. I mean the matrix A is multiplied on both the sides. I mean this is pre-multiplication, due to which we got this result. So X will remain as it is. In place of A inverse we got the already derived value. So it is 13, 8, 1, then 5, minus 10, 3, then after 3, minus 6, minus 5. And that is multiplied with matrix B. Matrix B already we got as 1, then after 3 by 2, then after 9. So let us find out the product. So I get here X is equal to 1 by 34. Let us multiply. Matrix multiplication we all of us know this is of order 3 by 3, this is of order 3 by 1. So the resulting matrix should be of order 3 by 1. 3 rows should be there, 1 column will be there. So I get here 13 plus 4 3 are 12, then after plus 9, then after in the second part it is 5, then after it is minus 15, then after plus 27, then in the last part I get 3, then it is minus 9, then after minus 45. Now I get here x equals to 1 by 34. We shall be getting the results as 25 plus 9, it is 34. In the second case 5 plus 27, or we can do one thing, 5 minus 15, the result will come as minus 10, then minus 10 plus 27 will be 17. Then in the last case it is 3, it will be minus 51, the result comes as minus 51. After this, by scalar multiplication, if I multiply each and every term of this resulting column matrix by this 34 which is lying outside as determinant value in the denominator form, we shall be getting 1, then this is half, then this is minus by 17, if I cut it, then it will be minus 3 by 2, minus 3 by 2. After this, what we shall be getting? After this our result comes as in place of x we can write, actually x is nothing but the matrix x, y, z, that is equated to 1, 1 by 2 minus 3 by 2. So this will imply x is equal to 1, y is equal to half, then z is equal to minus 3 by 2, and this is the required answer. Then coming to question number 12. In question number 12, given equations are, we have the equations x minus y plus z is equal to 4, then after twice x plus y minus thrice z, I get the value as 0, and then after what do I get? X plus y plus z is equal to 2. Now exactly in the previous way we have to proceed here with writing this in the form, writing this system of equations in the form ax is equal to b. What did I get? Such that a will be equal to all the coefficients 1, minus 1, 1 from the first row, from the second row 2, 1, minus 3 from the third row 1, 1, 1. Then after x will become x, y, z. Then b will be equal to, of course, 4, 0, 2, like the previous sum. The next step is what? To evaluate the determinant of the matrix A. So now determinant of A is equal to, what can I write? In determinant form I shall be writing, expanding along the first row, I get 1 plus 3, then after plus 1 I get 2 plus 3, then after 1 I shall be getting 2 minus 1. The result will come as 4 plus 5 plus 1, and the answer comes as 10, which is not equal to 0. Answer comes as 10, not equal to 0. Then after I shall be getting, therefore A inverse exists. Now for my convenience, I'm going to write down the matrix once here. That is what the given matrix is: 1 minus 1 1, then after 2 1, then minus 3, then 1 1 1. So this matrix I have to use for finding out its own cofactors. So I shall be writing here the cofactors of capital A are. Now I shall be listing this in this way, like the previous sum: A12, then A13 equal sign, then A21, I get here A22, A23, then here I get A31, A32, A33. After this, let us take the values. So I get here 1 plus 3, it is 4. Then after, for the second one, it is 2 plus 3, this is 5. 2, I get here 2 plus 3, but sign convention is negative, so I have to put minus here. Then after, what would I get? For the next one, 2 minus 1, it is 1. Then A21 is what? Minus 1 minus 1, means it is positive 2. Then A22, 1 minus 1 will be 0. Then for the third place, it will be, for A23, the elements will be 1 plus 1. This will be minus 2 for negative sign convention. Then A31, for A31, 3 minus 1, it will be 2. Then for A32, it will be minus 3 minus 2, means positive 5 due to sign convention. And for the last one, 1 plus 2, it is 3. So these are the cofactors I got here. So after this, I need to find out the adjoint of the matrix. Therefore adjoint of A is equal to, I can write here 4 minus 5 1, then 2 0 minus 2, then 2 5 3. Let us find its transpose. Its transpose will give us 4 2 2, then minus 5 0 5, then 1 minus 2 3. So this is the result for adjoint of A. So when I got this result for adjoint of A, we shall be getting, therefore A inverse comes as 1 by determinant of A into adjoint of A. Determinant of A, the value we obtained was 10. So I can put here 4 2 2, then after minus 5 0, this is 5, then after I get 1 minus 2, then after 3. Now let us come to the equation. Therefore for the equation Ax is equal to B, we have x equals to A inverse B by pre-multiplication with A inverse. I get here x is equal to 1 by 10. In matrix notation, it will be 4 2 2, then minus 5 0 5, then 1 minus 2 3. Then value of B can be written in the way 4 0 2. After this, we have to perform multiplication of these two matrices. Order will of course be 3 by 1. So I shall be getting here 1 by 10. Then after multiplication it will be 16 plus 0 plus 4. Then after minus 20 plus 0 plus 10. Then after I get 4, then 0, then after plus 6. And after this, what did I get? This can be written as x, y, z, that is equal to 1 by 10. Then after I get 20, then minus 10 it is, then 10. So on reduction I shall be getting x, y, z, that is equal to, I shall be getting here 2 minus 1, 1. So ultimately our answer comes as x is equal to 2, y equals to minus 1, then z equals to 1, and this is the required answer. Similarly, coming to the next question, this is question number 13. Given equations are, I get here twice x plus thrice y plus thrice z is equal to 5. After this, the next equation is x minus twice y plus z. I get here as minus 4. Then after I get thrice x minus y minus 2z comes as 3. Converting this into matrix equation form, what did I get? Writing in the form ax equals to b, we assume capital A as 2, then 3, then after I get 3 from the left hand side of the first equation. After that, from the second equation, left hand side gives us 1 minus 2, then after again 1, then left hand side of the third equation gives us 3, then minus 1, then after minus 2. Then after x is equal to x, y, z, of course. Then after b is equal to, I get here 5, then after minus 4, then after 3. So after this, what would I get? The determinant value we need to find out. What is the determinant of A? Now determinant of A is equal to, expanding along the first row, what I shall get? 4 plus 1 minus 3, then after minus 2 minus 3 plus 3, it will be minus 1 plus 6. So after this it will be 10, then after plus 15, and then after we get plus 15. So ultimately the result comes as 40 here, which is not equal to 0. Therefore I can write A inverse exists. Then after I shall prefer to write down the matrix here for my own use. Matrix A is obtained as 2, 3, 3, 1, minus 2, 1, then after 3, minus 1, minus 2. So after this I shall find out the respective cofactors. The cofactors can be evaluated in this way. So this will be A11 equals to, similarly A12, A13, then A21, A22, then A23, then after A31, A32, A33. Let's find out the values. We get the values, and directly I am writing down the values because these are exactly similar to the previous question. So the values will be I can write here 5, this will be 5, this will again be 5, this is again 5. The next case will be, this will be 3, then after minus 13, then after I get 11, after that I get here 9, then after 1, then after it is minus 7. So we shall be finding out the adjoint now. So adjoint of A, adjoint of A will be equal to, these can be written as 5, 5, 5, then 3, minus 13, 11, then 9, 1, minus 7. Let's find its transpose. This will be equal to 5, 5, 5, then after 3, minus 13, then 11, then after 9, 1, minus 7. After this I shall be getting, therefore A inverse is equal to 1 by determinant of A into adjoint of A. So let's find it out. It will be 1 by 40. The determinant evaluated was 40, and this is 5, 3, 9, then 5, minus 13, 1, then 5, 11, minus 7. So after this, what would I get? Therefore, for the equation Ax is equal to B, what shall I get? This implies x is equal to A inverse B by pre-multiplication with the matrix A inverse. We can write here x is equal to 1 by actually I should write here 40. It will be 40 here, then inside it we can write 5, 3, 5, 3, 9, 5, 3, 9, then after 5, minus 13, 1, then after 5, 11, minus 7 into value of B was 5, minus 4, then after 3. So let us check here. X is equal to 1 by 40, then after multiplication we shall be getting 25 minus 12 plus 27, then after again 25 plus 52 plus 3, then after we get 25 minus 44 minus 21. Now let's check what values we get here. Capital X is equal to 1 by 40. We shall be getting here 25 plus 27, it is 52. 52 minus 12, the result comes as 40. Then 52 plus 3, it is 55. 55 plus 25, the result comes again as 80. Then 25, actually 44, 21, both are negative. When added, it will be 65. 65 minus 25, the result again comes as minus 40. So after complete multiplication by the scalar term 1 by 40, we get the result as YZ. We get here 1, 2, minus 1. 1, 2, minus 1 here. So this will imply what? X is equal to 1, Y is equal to 2, Z is equal to minus 1. So this is the answer. Question number 14 is also similar to, exactly similar to 12, 13 and 11, 12 and 13. Thank you.